And then as soon as we get this problem done, then we can move on to the next step. Let's do this kind of a, to recap everything, review a little bit on the hyperbola, because hyperbolas were not on your quiz, right? All right, so here we go. How do we know this is a hyperbola? Well, it has really nothing to do with the coefficients. What does it have to do with? Subtraction. It's an x squared minus a y squared. It could be a y squared minus an x squared, that doesn't matter. It's just a subtraction, so that means we have a hyperbola. So we're going to put it in standard form just like we did the ellipse, right? So here we go. I'm going to put my x's together and factor out a 4. And I know I'm going to have to complete the square, so I'm just setting it up right now. So the 4 came out. Now what am I going to do about my y's? Just take out a -1. And that'll leave me with y squared. Here's one of the biggest areas of mistakes.
Plus 4y.
That's going to become a plus 4y. You can say, oh, Miss Ford, what's the big deal? It's just a negative sign. Well, that negative sign is going to impact the center. And since the center is where you get everything else from, it is a big deal. So be careful. All right, so now I'm ready to compute the square. So I'm going to put a, what here? 1 here, but that 1 is really a 4. I'm going to put a 4 here, but that 4 is really a -4. So I end up with just a 36 over there. Now what am I going to do? I'm going to divide everything by 36. I'm doing just what I do with an ellipse, right? So I'm going to have x minus 1 squared over 9, y plus 2 squared over 36 equal to 1. Does that look okay to everybody? All right, here we go. What's my center? I'm going to erase this to give myself a little more room for my picture. What's my center? 1, -2. What does this 9 right here tell me to do? It's under x. So I'm going to go sideways 3. And that 36 tells me I'm going to go up and down 6. All right, so I got those 4 points. And what will I do with those 4 points now? This is a hyperbola. Make a rectangle through those 4 points. Alrighty, there we go. Now I'll draw in my diagonals, making nice straight lines, hopefully. Now what do I have to decide? Which way I'm going to draw my hyperbola, because with asymptotes like these, I could be drawing it on the left or the right, or I could be drawing it on the top and the bottom. So I'm going to look at my equation, and I'm going to notice that x is first. So that means that my hyperbola opens in the x direction. So it's going to be the big fat one, like that. These 2 points right here then are the vertices of the hyperbola. So the next quiz you take, I'll have a hyperbola question. You have a V blank, vertices blank, and these are the 2 points that go there. Only 2 vertices for a hyperbola. This axis, what do we call this axis right here that joins the vertices? That's your transverse axis. So our transverse axis has a length of 6. What do we call the other axis, the other dimension of the box we made? The conjugate axis, and it has a length of 12. That's why that hyperbola is so fat. Now, this axis, the transverse axis, holds the vertices. Okay, yeah. Well, it does hold the vertices. All it holds the foci. In order to figure out what these foci are, these 2 points, in order to figure that out, I need to know how far it is from the center to the focus. So I'm going to need to figure out this distance right here. From the center, always from the center to the focus. I got to figure out that distance. How do I do that in a hyperbola? Center to focus, I'm going to add my denominators and take the square root. So what is that, 45? 3 root 5? Now that's the distance. That is not the coordinate. The distance. So you're going to start here at your center, and you're going to go forward 3 root 5. So where will you be if you do that? If you start at the center and go forward 3 root 5, what would be the coordinates of this point? 1 plus 3 root 5, comma negative 2. Remember, you're going in the x direction. And then you're going to back up the same distance, so this would be 1 minus 3 root 5, comma 2, negative 2. What else? Oh, we need our asymptotes. We need the equations of our asymptotes. So their lines, they're going to cross at what point? What point are both my asymptotes going to hold? 1, negative 2. So I'm going to use that point for both of them. One of them, though, is going to have a slope of what? Think about when you built the box. You counted up 6 and over 3. So isn't our slope negative 2 in this direction and positive 2 in that direction? You did the slope when you built the box. You started at the center and you counted up and over. So we can write our equations now, and you can do that whatever way you like, however you want to do your equations, you can. So I'll say y plus 2 equals negative 2, x minus 1. There's one of them. And there's the other one. So there are my 2 asymptotes. Now, does anybody have a question about something there? Because now we're going to go backwards. We're going to write some equations now. Anybody have an issue with that? All right. Then, let's try this. We have a hyperbola, and its foci are located here, and its vertices are located here. So that's the given. That's what we know. We have a hyperbola, and we know the foci, and we know the vertices. That's it. We're going to write our equation.
What do you know the center then?
What?
What do you know the center? What
wouldn't we be able to figure out the center? Well, what do you think, gang? Do you think we can figure out the center? That would be a very useful piece of information to have, for sure. Here's a vertex. And here's a vertex. Oh, by the way, what does the fact that these are the vertices tell me about my hyperbola right off the bat? If those are the vertices, what do I know about it? It opens up and down. Now, why is that important to me? Because I'm getting ready to write an equation, right? And it matters which letter comes first. Since I know because of those vertices, it opens up and down, that means that my what letter must come first? Y. So I've got this kind of equation. Just exactly like the ellipse equation, except that's going to be a minus in there. Would you agree that your center's in here somewhere? Mm-hmm. A center is going to be the midpoint of these two, isn't it? Always. So that would be 4, comma. What's the average of 3 and negative 9? 3 plus negative 9 divided by 2. Negative 3. Which means I'm going to have a y plus 3 and an x minus 4. You okay with that? Does this tell me anything else? Patty?
I want to say the y portion is divided by, is over 36.
Patty says this is over 36. Patty, what's your logic?
Well,
You're right, by the way.
It might be very flawed, but
No,
I just took the distance from a vertex to the center and then squared it.
Exactly. Because when we plot our vertices, if we were starting from the equation, what does the number under y tell us? That's our y radius number, right? That tells me to go up and down 6. And isn't that exactly what we did here? Went up and down 6. So you're exactly right, Patty.
The x radius, on the other hand, that's going to be a problem.
Well, we're going to be able to figure it out, but it is a problem because they didn't give me my conjugate axis, right? So I don't know how far I would go. But they did give me this. Could this be at all useful?
Yes.
Why would that be useful?
2 squared times 13.
Because it tells me that my foci are up and down 2 root 13. So the center to the focus is 2 root 13, which, by the way, is the square root of 52 if you unsimplify it. Now, what does that mean? That means what about these two numbers? If you add them together, they have to be 52. So this number has to be a 16. So we're doing what we did before, but backwards now. Instead of finding the distance from the center of the focus, we know what it is. So we have to work backwards to figure out what that number is. Okay? Let's do one more. One more of those. Let's say, oh, this one's a little different. This time, let's say we have vertices here and a conjugate axis with a length of 8. So it's a hyperbola. I know its vertices 0, -1, and 4, -1. And I know that its conjugate axis has a length of 8. Alright, so what do we know about this guy?
Starts off with x squared.
Starts off with x squared because clearly if those are its vertices, it's opening like this, right? So we're gonna have x squared minus y squared this time. What else?
Vertex is 2, -1.
This center is at 2, -1. That's exactly right. It's the midpoint. So that means x minus 2, y plus 1. All right. What else? The conjugate axis has a length of 8. That would be this one.
So it would be
So I'd be going up and down 4. So under y would be 16. The conjugate axis, remember, is the one that doesn't have the vertices. So it would be going up and down this time.
Can we just always, if we have the conjugate axis, can we just times it by 2?
No, I don't think so. Well, you have to take half and square it. So is that always going to work? No. No. All right, we have one more number left. Oh, it's an easy one. You got it. What do we know? What goes under the x? Why does a 4 go under the x? You're exactly right.
You go 2 to the right.
Because we go 2 to the right and 2 to the left, which means that number has to be a 4. Got it? All right, there's one special kind of hyperbola that we need to spend a minute talking about, and it is the perfect introduction to the next section that we're going to talk about. The next section that we're going to talk about is rotating conic sections. Now, this can be a really big deal. Rotating or unrotating conic sections can be a big undertaking. Back in the day when we did this, I made the kids had to get legal pads because every problem took that much space. They're a big deal. We're not going to go through all of that, but we are going to look at one rotation, and that is this. The presence of an XY term in your equation. Now think about all of the equations we've done. Think about the ones on the quiz you just took. Think about the ones in your homework. You have not had any XYs. You've had X's, you've had Y's, you've had X squareds, you've had Y squareds, but you haven't had any XYs. When you put an XY term into your equation, it means the curve has rotated. Now what does that mean? Well, that means instead of being horizontal or vertical, it's in a slant. Anytime an equation has an XY in it, it's a rotated conic section. Now, this is the simplest rotation we can consider because all it has is the XY. Now, here's what I want you to think about. If I were to get Y by itself, what does that kind of look like? You've seen it before many times. What does it look like? A version of the reciprocal function. What's the reciprocal function? BFF, y equals 1 over x. So this one's just been times by 9. And we know we can multiply by things and add things to them and everything else. This is the reciprocal function. What does a reciprocal function look like? Remember? The reciprocal function looks like this. Now what is that, kids? That's a rotated hyperbola. instead of having an axis that's vertical or horizontal, it's on the diagonal. Right? This equation looks exactly like that. Does anybody want to take a wild guess what the vertices of that would be? Let me get this out of here. Just think about it for a minute. Think about all the points. What times what gives you 9? Think about what do you think those 2 points might be? 3, 3, and -3, -3. Perfect. So if your equation had been xy equals, oh, let's say -16. Oh, wait a minute, -16. What's that going to change? Now it's going to be in quadrants 2 and 4 because you got to multiply a positive times a negative, right? To get -16. And where do you think these vertices might be? This one would be at -4, 4, and this one would be at 4, -4. Okay, now wait, one more. Because you know the whole world is not perfect squares. What if it's xy equals 5? Where are those vertices going to be? Well, first of all, it's going to be in quadrants 1 and 3, right? Where are those vertices going to be? What do you think that's going to be? Square root of 5, square root of 5, perfect. And this will be -5, -5. So, in an equation of the form xy equals a number, is everybody comfortable finding the vertices? First of all, xy equals a number is going to be a hyperbola. It's going to be a hyperbola every time. If that number's positive, it's going to be in quadrants 1 and 3. If the number's negative, it's going to be in quadrants 2 and 4. And everybody knows how to find the vertices. Right? What are the asymptotes? The equations of the asymptotes for every single one of these. X equals 0 and y equals 0. Every single one of these, the asymptotes are x equals 0 and y equals 0. Every single one of them. That won't change unless I pick it up and move it, right? Now what about the foci? Does it make sense to you that they would be located in that position? Or here, they would be located like this. Does that make sense to you that that's where they're located? The foci for this hyperbola would be 3 root 2, comma 3 root 2, and -3 root 2, -3 root 2. The foci for this one, -4 root 2, 4 root 2, and 4 root 2, -4 root 2. And for this guy, root 10, and -root 10. Oh, yeah, I forgot about that. Thank you, Mr. Torres.
Thank you.
Eventually, I would have remembered.
I wouldn't have, so I'm glad I was cleaning today.
Now, what in the world did I do to find the foci, and why does that make sense? So, number one, what did I do?
2.
I just multiplied whatever I had for vertices. I multiplied them by root 2. Why does that make sense? You know this. The transverse axis is the identity line. What angle is this right here? 45, isn't it? What do we know about 45, 45, 90 triangles?
1, 2.
Oh my gosh, the sides are in the ratio 1, 1, root 2. So to find the foci, we simply multiply, or whatever you had for vertices, by root 2. Every time. If you miss this question on the test, you're a goofball, because they are all done exactly the same. All right, so let's try one. XY equals negative 12. Okay, so here we go. Questions you're going to be asked. What are the asymptotes? What are the asymptotes always? X equals 0 and Y equals 0, period. The axes. Now, this particular one is going to be located in quadrants 2 and 4. Would you agree with that? Because you are multiplying two numbers together and getting negatives. So you have to have one positive and one negative. Where are my vertices? You're going to be asked for the vertices. Where are they? Square root of 12, which would be negative 2 root 3, 2 root 3, and 2 root 3, negative 2 root 3. And then you're going to be asked for the foci. Where are they going to be? Negative 2 root 6, 2 root 6 for this one. And 2 root 6, negative 2 root 6 for this one. Because how do we find the foci of an equation of the form xy equals a number? We simply multiply the vertices by root 2.
The angle is like 37.
Okay, that is a bigger issue, and we're not going to do that. The only rotation I'm holding you accountable for is this one, which is a hyperbola rotated 45 degrees about the origin. Because not only can we rotate it 37 degrees, but we can take it off the origin. We can take its center off the origin. And so then, you end up with a hyperbola that looks like this. All right, yeah, that's much more challenging. Okay, we're not doing it. Okay, we're not doing it. You are, however, responsible for this. This is a hyperbola. You need to know its center, which is the origin. You need to know its asymptotes, its vertices, and its foci. And if you've paid attention today, just now, and you study it, it's easy, because they're all exactly the same. Okay? Now, I said we're not going to do rotations, and what I meant by that is I'm not going to expect you to take a big, long, hideous equation, put it in standard form, and find all of its stuff. What I am going to expect you to be able to do, however, is this. You need to be able to look at an equation like this one and tell me what it is. Now, kids, I have told you that any equation of the form xy equals a number is a version of the reciprocal function, so it's a hyperbola. You got that? This is something different, because what did I stick in there? An extra y. So here are the rules of the new game. The new game involves equations of this form. So in other words, so far, you haven't had one of these. Have you had equations with x squareds, y squareds, x's, y's, and plain numbers? Have you had equations that had all those things?
Yes.
Yeah, and you complete the square and do all you do with them. Well, now I'm sticking in a b term. When there's a b term, all the rules change. You can no longer look at the equation and tell me what it is. I can't look at the equation and tell you what it is. well, the easy ones I can, but the harder ones, you can't look at it. You have to figure it out. And we figure it out using what we call the discriminant. Wait a minute. Have you heard that word before? Discriminant? You have. What is the discriminant?
The quadratic formula.
In the quadratic formula, it's the part under the radical, which is what? It's not 2a. 2a is in the denominator. What's under the radical? This is on video. I feel like I was back. What? B squared minus 4ac. B squared minus 4ac. Okay? That's the discriminant. Now, in your what we call second degree equations, in these equations right here, conic sections, that's going to be a conic section of some kind. We're going to figure out what it is. A is the coefficient on x squared. B is the coefficient on xy, that's the rotation. And C is the coefficient on y squared. So when I do the discriminant, the only things that matter are the two squared terms and the rotation. So when I evaluate the discriminant for this guy, what's my B? What's my B in this equation? 1 squared minus 4. What's my A? Now remember, A is your x squared. What's my A?
You don't have an A.
I don't have an A, so it's 0. What's my C? I don't have one, so it's 0. So the value of the discriminant for this equation is 1. When your discriminant is greater than 0, any positive number, when your discriminant is bigger than 0, you have a hyperbola. So you can take any equation that I give you, and you can figure out if it's a hyperbola by simply doing the discriminant. If you get a positive number, then you have a hyperbola. Let's try this one. All right, so what is it? I don't know what it is. I'm going to figure it out. So b squared, so that'd be 25, minus 4 times
2,
a, which is 2, times c, which is 0. Oh my gosh, that's a positive number. So what curve is that? That's a hyperbola. If you graph this, it would be a hyperbola. Awesome. Let's try another one. Is it what? You need, if it's not, you need to get it equal to 0. Now, I shouldn't even say that, because really, the only numbers that you worry about in these big long equations are A, B, and C. So whatever's happening over here really doesn't matter. Now, if by chance you had an equation where you had all this over here and the XY was over here, you need to move it over, because you got to get the sign on it right. But the A, B, and C are really the only ones that matter. All right, so there's a big one. It's got it all in there. This would be a monster equation if we were actually going to do it. Back to the point someone made earlier, there are formulas that give you the angle of rotation. So you could figure out from the equation what the angle of rotation is, that is how much this has been rotated. But before you would do that, you'd have to figure out what it even is. So what is it? Here we go, b squared. So that would be 1, right? Minus 4 times 2 times 3. Uh-oh, I don't know what that is, but it's not positive, right? That's gonna be a negative number. When your discriminant is negative, you have an ellipse. If the discriminant is a positive number, you have a hyperbola. If it's a negative number, you have an ellipse. Now, I've handled positives and I've handled negatives. There's really only one more thing that could happen to the discriminant. What if it equals 0? What if you worked it out and it actually equaled 0? That would mean a parabola. Now, circles are not part of this conversation. Can somebody explain why? Think about what we're doing. You can't rotate a circle. Well, you can rotate a circle, but if you rotate a circle, nothing changes, right? So they're not part of a rotational conversation. We rotate ellipses, hyperbolas, and parabolas. Very, very good. All right, let's do one more. On test day, I will simply give you some of these big equations, not very many, a couple, 2, 3 of these big equations, and say, what curve is it? So you're going to do the discriminant. You're going to know the rules. It comes out positive, it's hyperbola. Negative, it's an ellipse. 0, it's a parabola. Let's practice one more. All right, so one more. Here we go. Now, on the quiz, like we just took, everything we talked about up till now, you've been able to look at your equations and tell me what they are, right? You can't do that if there's an xy in the problem. So in other words, you can't say, oh look, a 2x squared plus a 2y squared, this must be a circle, because it's not. Because of that guy right there. When you put that guy in, you have to use the discriminant. Okay, is everybody understanding what I'm saying? All right, so here we go. What do we got? 16b squared minus 4 times 2 times 2. Uh-oh. Right there's your 0. That, believe it or not, is a parabola. If you graphed that, it would be a parabola. Rotated somehow, you know, situated somehow, but it would be a parabola. Everybody okay with that? Okay, all right.
What about the B?
What about what?
Where the E and the F?
They have nothing to do with that. Now, what the E and the F do is move your center or your vertex, in the case of a parabola, off of the origin. So this indicates the presence of a translation in the problem. You picked it up and put it down somewhere else. It has nothing to do with the curve itself, you know, in terms of what it is, or its angle of rotation. The angle of rotation comes right from these 3 letters. Okay, all right, good. Now, next. All right, so the next thing now we're going to do, this is just a fun-filled day. We've done all kinds of interesting things. So now what we're going to do, quit counting the moments till you get to leave. We are paying attention here. Look at Katie, what am I gonna?
I'm sorry, I didn't see the question.
All right, here we go. Take a look at these 2 points right here. Oh my gosh. They have 3 numbers, 3 coordinates. So instead of looking at points that have just an x and a y, we are now looking at points that have an x, a y, and a z. So we're going to look at some 3-dimensional things. So, we're gonna start by just doing some normal things that we do in 2 dimensions in 3 dimensions. So, for example, actually we did this before. This means okay. Everyone in the world knows that these hideously long periods are not conducive for math education. We all know that. We should be meeting like 30 minutes every day, okay? But it's what we have. I gotta make use of every moment because there'll be a day next week or later on this week where I won't even see you. So I really need you to suck it up and be tough, people. All right, here we go. This means we're gonna find the distance between P and Q. Now, we all should know, I'm a little hesitant after our discriminant fiasco, but we all should know the distance formula, right? How do we find the distance? Remember the radical thing? How do you find the distance between 2 points?
X minus X.
You subtract the x's, square it, subtract the y's, square it, add them together, and take the square root. In 3 dimensions, you do exactly the same thing. Only, in addition to subtracting the x's and squaring them, subtracting the y's and squaring them, now we're going to also subtract the z's and square them. So here we go. The distance between these 2 points will be 1 minus negative 3 squared, 2 minus 1 squared, 3 minus 5 squared. In other words, nothing is new. It's bigger, but it's not new. So we have the square root of 1 minus negative 3 squared, 16, 1, 4. So the answer would be the square root of 21. What if I said, let's find the midpoint of segment PQ? Well, how do we find the midpoint, like in 2 dimensions? Average, add them together and divide by 2. So we add the x's, divide by 2, add the y's, divide by 2, and now add the z's and divide by 2. So our midpoint, we're just going to find the average x. The average x would be negative 1. 1 minus 3 is negative 2 divided by 2. The average y is 3/2. And the average z is 4. Is that okay? Easy. Average, midpoint, average, middle value, middle, average. What if I wanted to know the coordinates of vector PQ? The vector from P to Q. What if I wanted to know the coordinates of that vector? Well, let's see. Going from P to Q, what's happening in the x direction? Negative 4. And in the y direction, negative 1. And in the z direction, 2. Is that okay with everybody? What does this mean? Magnitude? Now, do you remember how we found magnitude in 2 dimensions? How did we do that? That wasn't that long ago. How did we do that? We basically did the Pythagorean theorem, right? So what we did was we squared the x and squared the y, added them up, took the square root. So in 3 dimensions, we'll square this, and square that, and square that. Oh my gosh, that looks familiar. that make sense? Should that number have matched this number? Well, yeah. Isn't the length of PQ the same as the distance between P and Q? So we just did it a couple different ways. We did the vector approach on the magnitude of the vector, and here we did the straight old-fashioned distance formula. They're the same thing. I skipped chapter 7 for the time being. So we haven't seen equations that look like this. Does anybody know what that equation is? What that would look like if we graphed it, which we're going to do in just a minute?
I personally feel like there'd be a third plane.
That would be a plane. It's a plane. That is the equation of a plane, like the ceiling.
Yeah.
This is the equation of a plane.
This looks like we're getting into the realms of 3D.
We are, Patty. As soon as you put that third coordinate in there, you're in 3 dimensions. This is the equation of a plane. Now, what does that look like? How are you going to graph that? Well, we're not going to do any super sophisticated 3-dimensional graphing, but we can graph planes. Those are easy enough to do. First of all, we have to set up our 3-dimensional coordinate axis system, which is like the corner of the room, where that and that and that all come together. Now, these are right angles. Do you understand that? I've had to flatten it to put it on the board, but those are right angles. That's like the corner. Look down at the corner of the room if you're having a hard time visualizing it. This is the positive x-axis, this is the positive y-axis, and this is the positive z-axis. That's just the way it's traditionally drawn. Like when you set up a regular Cartesian plane, this is x and this is y. That's tradition. That's just the way we do it. So when we graph in 3 dimensions, this is the setup that we use. To graph a plane, it's really simple. Let's use the idea of the intercepts. Now, what do I mean by the intercepts? Where I cross the x-axis. All right, that means y and z have to be 0. If I'm on the x-axis, then y and z are 0. So what is my x-intercept? 2. So I'm going to put a point right here, and that's the point 2, 0, 0 on the x-axis. Now, if your intercept had been negative, you need to envision the negative axes are all here too. We usually draw those with dashed lines. So a negative x-intercept would have been plotted back here. Now, what's my y-intercept? Well, my y-intercept is 1. So this is the point 0, 1, 0. Your x-intercept has a y and z of 0. Your y-intercept has an x and z of 0. And what's your z-intercept? 4. So this is the point 0, 0, 4. Now, from geometry, how many points does it take to determine a plane? 3. Do I have 3? I do. So I'm going to connect those 3. And right there is the picture of the plane represented by that equation. So we're not going to get scared when the question says, graph this equation. If the equation looks like this, it's a plane. Take this away and it's a line. Make a line 3-dimensional and you have a plane. Okay? Easy enough. All right, we have one more thing. And, oh, stop it, one more thing. And then we'll be actually almost done with everything. We'll have a couple more things to do. All right, so one more thing. Come on, hang with me. Be tough, be strong. This was on your quiz. What's this the equation of? That's a circle with a center at the point 2, -3, and a radius of 5. All right? Let me stick this on here.
No.
All right, now wait a minute. Without this, it was a circle. With that, now it's going to be a sphere. This is a sphere. Where is the center of this sphere? 2, -3, 1. And what is the radius of the sphere? 5. Now, what are you going to do if you run into this? Now, first of all, you're going to recognize that's a sphere because you have an x squared, a y squared, and a z squared. Wouldn't that be what happened here if you FOILed everything out? That's a sphere. And your job is to find its center and radius. So you need to make that equation look like this one. That means we have to complete the square 3 times. So x squared minus 8x plus blank. Y squared plus 4y plus blank. Z squared minus 2z plus blank equals 6 plus blank, blank, blank. So again, just like with the distance formula, just like with the vector, just like with the midpoint, no big deal. Everything is exactly the same, just bigger, more of it. So what completes the square here? 16. Here, 4. And here,
1.
so we have x minus 4 squared, y plus 2 squared, z minus 1 squared, and it adds up to 27. Did I add right? 22, 23, 27, yeah. So where's my center? 4. Watch it, 4, -2, 1. And my radius is square root of 27, which is 3. All right, those of you that need to go to your field trip can go ahead and go. The rest of you, take a deep breath. Say, oh my gosh, I've learned so much math today, I can hardly stand it.